Academic Physics, Waves and Sound, page 23. Important day today. You will be assessed Thursday this week, and there will be a problem like this. This readout shows pressure versus time in seconds for two sound waves. One is a high frequency wave. It has more cycles in this amount of time than the other. The other one, though, has greater amplitude. You can see that it has greater change in its pressure, so it has greater amplitude. We want to figure out, we want to respond to these questions having to do with period and frequency. So, first of all, which sound has the higher pitch? Well, that means higher frequency. That would be wave A. And wave B has the greater amplitude, as I said. The approximate period of wave A is the time between successive crests, or the time for one cycle. And for wave A, that point and that point would be one full cycle. And reading this graph goes from 0.0001 seconds to 0.0004 seconds. These are actual values. And so that's 0.0003 seconds is the period. Frequency is 1 over the period, and here is that calculation. Calculating the frequency of that wave would be 3,333 hertz. If we know the speed of sound is 340 meters per second at room temperature, we can use the wave equation that connects velocity, frequency, and wavelength to figure out the wavelength. So starting with that equation, we solve for lambda, which is wavelength, divide both sides by frequency, so we get lambda equals velocity divided by frequency. That's the given velocity, that's the calculated frequency. So 0.1 meters or 10 centimeters, about 4 inches, is the wavelength of a sound wave at room temperature with that frequency, 3,333 hertz. The other wave B, has a frequency of 1 over its period. Its period has to be gotten from the graph. And that point there is close to 0.0008 second mark on the clock. That one's close to 0.017. Actually, there's two zeros, 0.0017. And the difference between those points in time is 0.0009 seconds. So that's the measured period. And 1 over the period is the frequency. That's 1,111 hertz. And again, if we use that velocity for the speed of sound, we can figure out the wavelength using the wave equation. Use the same setup as before. Wavelength equals velocity over frequency. There's the velocity. There's the frequency. 0.3 meters is the wavelength. It's about a foot. So that lower frequency wave has a longer wavelength.